What is the difference between mass and weight of an object? Will the mass and weight of an object on the Earth be the same as their values on Mars? Why? The mass of an object is the amount of matter present in it. It is the same everywhere in the universe and is never zero. It is a scalar quantity and its SI unit is kilogram. The weight of an object is the force with which the Earth attracts it. It is directed towards the center of the Earth. The weight of an object is different at different places on the Earth. It is zero at the Earth's center. It is a vector quantity, and its SI unit is the Newton, N. The magnitude of weight equals mg. The mass of an object will be the same on the Earth and Mars, but the weight will not be the same because the value of g on Mars is different from that on the Earth. Question 1. Free fall. Whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. 2. Acceleration due to gravity. The acceleration produced in a body due to the gravitational force of the Earth is called the acceleration due to gravity. 3. Escape velocity. When a body is thrown vertically upward from the surface of the Earth, the minimum initial velocity of the body for which the body is able to overcome the downward pull by the Earth and can escape the Earth forever is called the escape velocity. 4. Centripetal force. In uniform circular motion of a body, the force acting on the body is directed towards the center of the circle. This force is called centripetal force. Kepler's first law. The orbit of a planet is an ellipse with the Sun at one of the foci. Kepler's second law. The line joining the planet and the Sun sweeps equal areas in equal intervals of time. Kepler's third law. The square of the period of revolution of a planet around the Sun is directly proportional to the cube of the mean distance of the planet from the Sun. Thus, if r is the average distance of the planet from the Sun and t is its period of revolution, then t squared equals k times r cubed. E. If the value of g suddenly becomes twice its value, it will become 2 times more difficult to pull a heavy object along the floor. Why? Answer. To pull an object along the floor, it is necessary to do work against the force of friction between the object and the surface of the floor. This force of friction is proportional to the weight, mg, of the object. If the value of g becomes twice its value, the weight of the object and hence the force of friction will become double. Therefore, it will become 2 times more difficult to pull a heavy object along the floor. What types of forces are you familiar with? Answer. The gravitational force between the Earth and the Moon, the electromagnetic force between 2 charged particles in motion, the nuclear force between a proton and a neutron in the nucleus of an atom. What do you know about the gravitational force? Answer. The gravitational force is a universal force, that is, it acts between any 2 objects in the universe. Number 1. Newton's first law of motion. An object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. Number 2. Newton's second law of motion. The rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Number 3. Newton's third law of motion. Every action force has an equal and opposite reaction force that acts simultaneously. What would happen if there were no gravity? Answer. There would be no gravitational attraction between any 2 particles, and hence no formation of the solar system, galaxy, etc. Will your weight remain constant as you go above the surface of the Earth? Answer. No. As we go above the surface of the Earth, our weight will go on decreasing. Number 1. The value of the acceleration due to gravity, blank, as we move from the equator to a pole. Answer. Increases. 2. If the Earth shrinks to half of its radius, its mass remaining the same, the weight of an object on the Earth will become blank times. Answer: 4 times. 3. The SI unit of weight is the blank. Answer: the Newton. 4. The CGS unit of weight is the blank. Answer: the dyne. 5. The weight of a body is blank at the poles. Answer: maximum. 6. Due to the blank force, the Earth attracts all objects towards it. Answer: gravitational. 7. The acceleration due to gravity does not depend on the blank of the body. Answer: mass. 8. According to Kepler's second law, the line joining the planet and the sun blank as in equal intervals of time. Answer: sweeps equal areas. 9. According to Kepler's first law, the orbit of a planet is in blank with the sun one of the blank. Answer: an ellipse and foci. Question: state any one characteristic of gravitational force. Answer: gravitational force between two particles does not depend on the nature of the medium between them. Question: name the force that keeps a satellite in the orbit around the Earth. Answer: the gravitational force due to the Earth keeps a satellite in the orbit around the Earth. Question: name the force due to which the Earth revolves around the Sun. Answer: the Earth revolves around the Sun due to the gravitational force of attraction exerted on it by the Sun. Question: what is the relation between the SI unit of weight and the CGS unit of weight? Answer: the relation between the SI unit of weight, the Newton, and the CGS unit of weight, the dyne, is 1 Newton equals 10 raised to the 5th dynes. Question: what is the value of the acceleration due to gravity at the center of the Earth? Answer: 0. Question: what are the factors on which the maximum height attained by a body thrown upward depends? Answer: the initial velocity of the body, the acceleration due to gravity at that place, the buoyant force, and frictional force due to air.